Hello, dear friends. Greetings of the day. I'm back in the channel that is Hospitality Education PPT. And as you know that we are conducting crashing of the projects, project network analysis under facility planning. And today precisely in this particular session, we are going to discuss about crashing of project network. We'll try to deliver on the concept development about the crashing of the project network. So without wasting further time, let us welcome you all to the channel for this session. Let's go. In our last session, we have already discussed about the CPM, the concept, and also we have thoroughly discussed about the part, PERT, and also we have clarified about different kind of floats and relax and how to find out the critical path, and depending on that the project duration that we have discussed thoroughly and practiced as well. Today, this session, the scope of study is one step developed further, and the scope of study will be, we are going to talk about the word crashing and understand that what is called crashing exactly. And also along with that, we are going to discuss the concept through example, through a network, sample network. We'll try to develop the concept of the crashing of any project network, and then why we crash, what is the aim of it, and what is the relationship with the time, that is the cost and project duration relationship. We are going to discuss on that, and finally we are going to discuss about the illustration of crashing. So this is the small area we have taken up today that we are going to discuss, and in between, if you are having any questions, any doubt in your mind, please put me in the comment box. We'll get back to you with the proper clarifications for that. Okay, so with that, let us begin our session. Crashing of our project network. What is that exactly? Before we go for exactly the crashing of our project network, we have already studied the use of CPM and PART to identify the critical path for a project problem or a project network. That already we have done. Those who have joined first time today, I'll request you that you can go to the earlier sessions in your free time to make your understanding very clear and transparent on this. Through the earlier sessions, we have come to know that how to find out the project duration by considering all the activities, and then the earliest start time, earliest finish time, latest start time, latest finish time, everything we have discussed earlier. Now the question comes that can we cut short the project completion time? Suppose a project is, as per your calculation, CPM and PART, that you have calculated a project will be completed by 15 days. The project will take 15 days to be completed. Now the question is that can we make it by 14 days or 13 days or lesser time? That's the question. And in this session that will be answered. Project duration time can be reduced. How it can be reduced? By assigning more resources to the project activities. Obviously, if you need to complete the project instead of 15 days by 14 days, to reduce it by 1 day, what we need to do, we have to employ more resources in the project. It can be in terms of manpower. It can be in terms of equipments or resources, or it can be in terms of material, which will involve the money. But doing this would somehow increase our project cost, obviously. That is very natural. If you want to reduce it by incorporating more manpower, more resources, more material over there, obviously your project cost is going to be high. Then what is the purpose of it? What is the benefit out of it? That we are going to discuss now. So, crashing means what? The reduction of project duration is called crashing. It's basically nothing but the cost and time management. And this crashing will be the systematic crashing. It's not that as per your sweet will, you will just reduce it by 1 day or 2 days somewhere in the activities. There will be a systematic crashing process, and crashing means here reduction of the project duration time, which is nothing but dealing with the cost and time management. Clear? Fair enough? Now, the project crashing is a method for shortening the project duration by reducing one or more critical activities to a time less than normal activity time. Now, if we just trace back our previous knowledge, there we have learned that the project duration or the critical path is basically the longest path in the project network, starting from the first node to the last node. So these critical activities where there is no slack, no relaxation is possible, no delay is possible, then only it will become the critical activities. So if you want to reduce the project duration time, you have to reduce the activity by number of days or number of hours as per the duration on the critical activities only. Because other than critical activities, the non-critical activities, there you are having sufficient relax or the slack time. So if there you reduce a day or days, number of days, it is not going to reflect in your total project duration. So it will be reflected only when you are crashing the activities on the critical path line. You got my point. So any crashing should be done on the critical activities only, not on the non-critical activities. That is for sure. We attempt to crash some critical events by allocating what? More resources to them, so that the time of one or more critical activities is reduced to a time that is less than the normal activity time. So you have to employ more resources there on the critical activities, then only the project duration will be reduced. And that is what we are going to do. Now let us take up, this is also, before we go to the next, this process, the way the crashing will be done, that is also known as a trade-off concept. Remember that it is known as the trade-off concept. Clear? Now, let us try to make the concept of crashing in a project network in terms of example in front of you on your screen now. And let us take up one sample network here. You can see that the project is starting from node 1 and it is ending at node 6. In between, there are multiple activities, and all the activities, they are termed like A, B, C, D. And besides that, we have also mentioned their actual duration time. Okay. Now, if you want to, we have mentioned that if you want to crash the project, then you have to do it on the critical path. So then we have to first find out what are the critical paths, and we'll go by the path method as we have learned. And what is that? Here we can see what are the possible paths. First possible path is ADH. That means you are starting from A, going to D, and from D to D is then next is H, and reaching to node number 6. This is one path, and the duration of this path is, it is calculated 2 days plus 4 days plus 2 days, that means altogether 8 days. Clear? Then another one path is BH, starting from node 1 going to node 4, that is activity B, plus from node 4 to node 6, activity H, and this is the path, one of the possible paths, and here the duration is total 5 days, that you can see on your screen, that B activity will take 3 days, H activity will take 2 days, so altogether 5 days. So this is one of another one possible path. Path path number 3, here it is 1 to 3, then that means C, then E, and then H. So 1 to 3, 3 to 4, 4 to 6. And if you calculate the total duration as per this network, it is 11 days. Fine. Then another one path is there, path number 4, which is C, then F, and then G. CFG. And if you calculate the duration allotted for that, it is 4 plus 2 plus 3, that you can see 4 plus 2 plus 3, it is all becoming 9 days. So these are in front of you, the possible paths along with their duration in terms of days. Clear? Now out of these, which one is the critical path supposed to be? The longest path in the network. What is that? We can see the path number 3, that is CEH. Duration is 11 days, which is the longest path, and that is your project duration time. So this is basically the area we are talking about. That means C, E, and H. This is your 11 days. So you can see 4 plus 5, 9, 9 plus 2, that is 11 days. Okay. And so this is what exactly, according to our theory, it is the critical path. It is supposed to be the longest path in the project network, and also simultaneously it is the shortest duration of the project time completion. So 11 days the project will be completed. Okay. And this is your critical path. That is why we have given some different kind of colored arrow to identify that these C, E, and H is your critical path now. So this is identified. What else we get to know out of this? That means the project duration is 11 days, and that is the earliest finish time on the last node, which is represented with letter E. So E will be, on the last node will be 11. That is for sure. Now the concept of crashing is coming. If you want to crash the project, even if you want to make it by 10 days or 9 days or lesser than that, then whatever you are going to do, we have to reduce the durations on the critical path only, not in anything else. So either you have to reduce here on C or E or H, and there is a system for that. That also you are going to learn in coming days. What does it mean exactly? Suppose, let us take one example. Let us take up the activity C, and it is completing by 4 days. This is the critical path. If you want to reduce the project duration time, then you have to reduce the time here. I'm taking it for example. So instead of 4 days, if we can make it by 3 days, then what will happen? Your earliest finish time on node 6 or the project duration time will be also reduced by 1 day, isn't it? So instead of, earlier it was 11 days project duration time, now it has reduced to 10 days because you have crashed one of the critical parts in the project network, and in this case, as example, we have reduced 1 day on the activity C. You got my point? So this is the total concept of crashing of the project. But what is the aim of crashing? Aim is, one thing is very clear, that aim is to reduce the project duration. It is basically dealing with the project duration time. And the purpose is, the aim is to reduce the project duration time. You can see it is given by the down arrow to make you understand that the project duration time will be reduced. That is the aim. And what will happen if you reduce the project duration? It can give you two situations. One is that the total cost, either it will be decreased or it will be increased. Increased part we understand, because we have told you that if you want to crash the project, then you have to employ more resources, more manpower, more machine over there. So obviously there, the cost of all these will be involved. So total cost of the project will be increased. But also we have mentioned that in some cases it will be decreased also. How? To clarify this idea, let us take up one example. That is, suppose next winter, coming winter, you know, in your city, there will be one gala event. There will be lots of tourists will be visiting the place for some international events. So to get that business during the Christmas time, it is very urgent that you need to develop or renovate the hotels. Maybe one floor or two floors or the entire hotel, depending upon your situation and requirements. Now let us take up that to complete that renovation part. If you calculate the project duration time, say it will take 6 months. And if you say that 6 months, before that only, before completion of the project by 6 months, the event will start in your city. So what will happen if the event starts and if your hotel is not ready by that time? What is going to happen? That means you are going to lose some revenue. So that is a kind of loss. So what we can do now, you want to complete, instead of 6 months, you have decided that it will be completed by 4 months. What we can do, we can deploy more resources, more manpower, more money over there. So what will happen? Say, now to complete the project in a normal time period in 6 months, say suppose you have to spend, say, 1 crore of rupees. Let us take it in that way. Money is not the factor out here. I am just giving one example. And if your project is going to be completed by normal time, and as we know that by that time your event in the local area will start, so naturally you're going to lose the business. Maybe your business will be losing another 50 lakhs during that period. So that means your cost will be 1 crore of rupees plus 50 lakhs you're going to lose, because you're not going to earn out of that. So if you can reduce it by before 1 month of the actual event starts in your city, or by 2 months, whatever, and if you see that for that you have to give another 25 lakhs as a resources to invest, so that it will be completed before the actual event starts in the city. So then what will happen? So your project cost is, normal cost was 1 crore rupees plus another 25 lakhs. And that means 1 crore 25 lakhs, that will be your total cost of the project. It is actually getting increased. But if you consider the loss of revenue, if it is not opened before the event starts, then you are going to lose another 50 lakhs of revenue. Instead of that, you are spending 25 lakhs out here extra, and you are getting 25 lakhs. So in that way, your total cost indirectly is getting decreased. You got my point? So that is the aim of the project. And What is the relationship between the time? Here, two types of time we can see. One is the normal time, which is represented by Tn, normal time, and another is the crash time. If we take up the example that earlier project network, it was taking 11 days time, and we have crashed one day on the critical path. So instead of 11 days, it became 10 days. So you can see earlier it was 11 days, now it is crash time is 10 days. So which one is greater? So normal time will be always greater than the crash time, because crash time is always reduced, crashed down. You got my point? That is the relationship. Fine. Now let us see what is the relationship between cost and project duration. Okay. Cost means here we are having four things: man, machine, material, and money involvement. That is the cost. And there are three different types of cost in the project. One is the normal cost, which is represented by CN. Another one is crash cost, which is represented by CC. And another one is overhead cost, that is represented by CO. Fine. These are the three costs involved in a project. What about the normal cost? Normal cost is to complete a project in a normal situation, whatever cost is required, that is known as a normal cost. Now, this normal cost, suppose to complete a building, you may have to require, say, 10,000 bricks. I'm just giving you one example. So, whether you are making that building or room today or after 2 months, the material will remain the same, always 10,000 bricks, because that is the requirement for completing a room or the whatever you are making the project. So that means what? That cost will be always the normal cost, and that is independent on project duration. Whether you complete it by 2 months or you are completing by 3 months, your material cost will remain the same in a normal situation. So that is a normal cost. It is independent of project duration. Fine. Now, and also it is never changes, because 10,000 bricks will be always required to complete that room, to develop that room. Okay. Like that, there are other costs as well. For example, now we are talking about the crash cost. What is the crash cost? The extra money or extra resources you deploy to complete the project lesser than the normal time period. So instead of 11 days, say for example, you want to complete it by 10 days or 9 days. To complete that by lesser time, we have to employ more money, more extra resources over there. So that means, what is the relationship now? It is dependent on the project duration. If you want to crash it for one day, a type of cost will be involved. If you want to crash it by 2 days, more cost will be involved, obviously. So it is dependent on the project duration time. So crash cost will increase with decrease of the project duration. More you want to decrease the project duration, your crash cost will be higher, higher, and higher. So it is increasing when the project duration is getting decreased. You got my point? Fine. Now, what is overhead cost? Overhead cost is the indirect cost associated with project duration. It has got nothing to do with the resources. It has got nothing to do with the activities. But to continue with the project, you need to have some kind of indirect cost involved in that. Maybe the daily expenses, the stationaries, the rent, hiring of the staff. So all these things are very much involved over there, overheads. So these are all indirect cost. The hiring means the salary of the staff. So it is dependent on the project duration. Number of days, it is dependent on that. So this cost will decrease with the decrease of project duration. If project duration is decreased, your overheads will be also decreased, obviously. So out of these three costs, normal cost is independent on the project duration, never changes. Crash cost will be increased whenever you are decreasing the project duration. Overhead cost will be also decreased along with the decrease of the project duration. That is understood. Do you have any questions? Please, if you do have questions, definitely put me in the comment box. I'll be giving you the proper answer or more examples to make it absolutely transparent in your mind. So this is the cost structure in the project. Fine. Now let us see the illustration of the crashing. Let us take up one example. You can see that here we are having one activity which is starting from the ith node, completing on the jth node, and normal time is 5 days. To complete that activity, you have normal time, that is 5 days. And the normal cost is 1000 rupees. Let us take as an example. Now, crash time, TC means crash time. You want to make it by 3 days. You want to crash it by 2 days. And to do that, crashing cost will be 1400 rupees. Crashing cost will be 1400 rupees. This is the scenario. Okay. Now let us see in terms of a graph. Here you can see the x-axis and y-axis represent the time, y-axis represent the cost, and you can see the normal time is always greater than crash time. So you can see that this is your normal time here, and this is your crash time. Normal time it was earlier in this position higher, crash time is less, and here cost, normal cost was here, and due to crashing cost has become higher. Okay, now if you want to connect this in terms of graph, straight line, you will see that this is the point, and also you can see this is the point. Now this was your normal time. At the time the normal cost was this. As we have reduced the normal time to the crash time, time has reduced, but your cost has become higher. So you can see few things out here. One is that there is a point A, there is a point B, and there is a point C. Now look at these points. BC. BC is the difference between normal cost, normal time, and the crash time. So this is basically the value of BC. If you see, that is Tn minus Tc. That is the difference. Okay. Now in this case, AB is what? AB is the difference between the crash cost minus the normal cost. Crash cost minus normal cost, this is the difference. So these are two differences we are getting. If you connect A and C, we get a triangle out here. And this angle is known as the cost slope, which is represented by theta. This is known as the cost slope. What is the cost slope? It is a crash cost per day, right? Or is known as the cost slope or crash cost per day, which is represented by tan theta. Perpendicular, AB is the perpendicular, BC is the base. So perpendicular by base is known as the, this angle is represented, is known as the tan theta. Fine. Now let us take up this example. According to this graph, it is AB by BC. AB is what? CC minus CN, then crash cost minus normal cost, crash cost minus normal cost, and BC. BC is Tn minus Tc. Okay. This will give you what? Now let us put the value here. Value is what? Cc minus Cn. Crash cost was 1400 minus normal cost was 1000. So that we have written down out here. And Tn minus Tc. Tn was normal time 5 days and Tc was 3 days. So altogether, if you calculate, it is difference is 400 by 2 days. So if you calculate, it becomes rupees 200 per day. That means this activity normal time was 5 days, crash time was 3 days. That means you are crashing it by 2 days. And if you want to crash it by 2 days, every day your cost slope is 200 per day. That means every day you have to spend extra 200 to get the activity crashed by 2 days. Clear? That is the idea. Now, how we are going to do that? That will be definitely discussed in the next class. If you have any questions, again I am saying that you can put it forward in the comment box, or else you go through it repeatedly after this session also, because it will be uploaded in the YouTube, and then you can find out what is not understandable by you, we can clarify it further. Now, depending on these, let us find out what is the total cost of the project. So total cost of the project is what? Normal cost plus crash cost, because for crashing by number of days, you have to give more resources. Resources means money. So that is the crash cost as we have calculated out here, plus the overheads. Overheads will be there. All three costs we have discussed. Okay. That will be your total cost. That means the given cost to complete a project, normally a given cost will be there. So given cost plus what is your crash cost? Number of days multiplied by crash cost per day. So in this case 200 rupees. Suppose you are crashing it by 2 days. So 2 multiplied by 200, that is 400 rupees for the total project or this for this activity. Plus the project duration time. Project duration time multiplied by cost per day, the overhead cost per day. Overhead cost will be there. If you are continuing a project for say 5 days, every day there is a cost incurred, that is on the overheads, and that is known as CO. And if you reduce it by 2 days, so that cost will be less, because it will decrease according to the decrease of the project duration that we have already mentioned. So these three, whenever you add on, ultimately what you get, that is your total cost. So whenever you're going to find out a total cost, you need to know the normal cost, you have to calculate the crash cost, and also you have to find out the overhead cost. Overhead cost is a project duration multiplied by overhead cost. Crash cost is a number of days crashed multiplied by crash cost per day, or the cost slope per day. Okay, and normal cost will be given cost to you in the problem. So that is our how we are going to calculate, do the crashing. And what is crashing, rather, not how we have not discussed today, how we will be discussing in the next class. Today we have clarified what are the basic concept of crashing, and then how the total cost of the project will be calculated. So thank you very much for your attention for the session. Hope you have understood it. If not, never mind. You can go through this session once again repeatedly, because this is your classroom, which is away from your normal classroom. Anytime, anywhere, you can take up this lesson for your better and best understanding. And if you have liked the session, don't forget to subscribe it if it is not done. Also press the like button and press the bell button, so that you get the alarm in the right time whenever a new video will be uploaded in this particular channel. And this channel is dedicated for you all. And your feedback is very, very important for me. If you have any feedback, any doubt, any clarification you need, please put it there in the comment box. I'll be there to give you the right answer for that, so that it will be helpful for you to solve the problem. So up to this today, next week, again we are going to start with, actually we'll take up a problem of how to crash a project network systematically. I have used the word systematically. Today we have developed only the concept, and next week we'll learn how to do that actually mathematically over there. Okay, that is also very simple. Hopefully that will be also give you the actual knowledge about the crashing of the project. So till then, thank you very much. Take care, and I'll meet once again. Bye bye.